This time on Battle Factory. A remote-controlled eye in the sky. A hard-shell case that's an ER you can drop from a plane. How to keep yourself safe from the storm and hidden from prying eyes. And a monster truck that can really take a bullet. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When this construction of cogs, cables, and computer software hits the air, it'll become a flying eye in the sky and a high-tech bird of prey. UAV stands for Unmanned Aerial Vehicle, but these remote-controlled flyers, used for long-range reconnaissance and armed combat, are better known as drones. They come small enough to fit into a backpack or scale right up to a full-size fighter jet. It can outfly manned aircraft, staying aloft for over 24 hours at a time, often controlled via satellite link from a world away. The ING Robotic Aviation Responder is a surveillance drone that can reach speeds of 70 kilometers per hour. Weighing in at 45 kilograms, the $80,000 HEL Drone is stable in extreme weather conditions and 60-kilometer winds. The HEL Drone is currently deployed to East Africa, where the military use it to monitor border incursions. The HEL Drone breaks down into the motor, the drives, and the frame. The mini-copter is made on a frame of carbon fiber, which is 10 times tougher than steel. The rest of the body is composed of strong, lightweight fiberglass, which won't disrupt the radio frequency signals that control the drone. The main gear drives the aircraft's main rotor and tail. All teeth on the gears are manufactured on a diagonal instead of straight up and down. This minimizes noise and vibration throughout the frame, which maximizes stability and stealth. Just like a full-sized helicopter, the drone is based on angled elements that provide lift and prevent the aircraft from spinning out of control. There are two drive systems, one in the main body of the frame and one in the tail. This two-way drive helps to stabilize the drone so it doesn't spin and helps with the yaw, or left and right turns. The drives are made of CNC machined aluminum. First, the tail drive is assembled. Next, the main drive is constructed. The main drive is responsible for the lift of the drone. Its curved holders steady the aircraft and minimize spin. Surveillance drones were first used extensively during the Vietnam War. Dubbed Firebees, they were equipped with conventional cameras and ran reconnaissance missions. Not much change for UAVs for 20 years, until drones were able to see details from half a kilometer up and transmit those images in real time. And the sound of a drone often meant an attack was going to follow. So, in February 1991, after a U.S. battleship had devastated the Iraqi defenses of Failaka Island near Kuwait City, the Navy sent an unarmed drone at low altitude over the island. When locals heard the drone's signature sound, they figured the low-flying aircraft was about to direct another precision strike. The troops started surrendering to the drone's tiny camera. It was the first time in history that people surrendered to a robot. Assembly begins with the landing gear. The lower landing portion is made of lightweight aluminum. The raised legs allow for 8 inches of clearance for mounting cameras and large sensors. The copter is wired and the onboard computer and power source are installed. The 500-watt battery-powered motor will reach speeds of 70 clicks and run for about 40 minutes without a recharge. Finally, the propeller blades are inserted into the main and tail drives. The responder is made to carry a DSLR camera, which takes super high resolution stills and video from as high as 275 meters up. Top priority for the drone's test flight is to make sure the UAV is vibration-free. Even the slightest rattle makes for a bumpy ride, a drained battery, and blurry images. Drones are on the rise. Whether it's deployed for high-altitude surveillance or targeted air assault, the drone is a powerful and controversial combination of human skill and robotic technology, and a long-range look at the future of warfare. Coming up on Battle Factory, a shock-proof, leak-proof carrier you can drop out of the sky, and a DIY solution to surviving in the woods. These granules of lightweight plastic will be melted and molded into a hard-shell, waterproof case that can be an emergency ward in a box. Until the early 1960s, military equipment and supplies were packaged and transported in wooden shipping crates. They were heavy and had to be pried open with crowbars, and once unloaded, they were trashed. These days, the shipping case is made from composite plastic. Lighter and more rugged than wood, the case can be clean enough to carry medical supplies and tough enough to drop out of a plane. They seal tight to keep out water, weather, and sand, while maintaining a constant atmosphere and sterile environment inside. The ECS case breaks down into the hardware and the body. Grains of sand-colored polyethylene are weighed out, then shoveled into a mold. Then a lid is put on, and it's secured to a robotic arm. First, the mold is rotated so the polyethylene grains inside are distributed evenly. Next, the arm moves into a large oven that heats the poly to 300 degrees Celsius for 20 minutes. Once heated, the granules of poly melt together to form a solid plastic that conforms to the shape of the mold. Then, it's shifted to a cooling bay, where an industrial fan dries it to a hard finish. Still hot to the touch, the cases are pulled from the mold. During molding, solid foam is placed inside the shell. As it cools, the case shrinks approximately 6 millimeters, and the foam inserts help maintain its shape. A blanket prevents it from cooling too quickly. Once it's cooled down, the foam inserts are punched out. After a further half an hour, the excess plastic edging, called the return cap, is shaved off. A blowtorch smooths out the edges, and a plastic soldering iron seals any spots where the shaving created holes. The surface is buffed, and an angle blade X-Acto knife trims off the remaining plastic shards. Finally, a flattening agent is sprayed to remove the unwanted reflective gloss left by the blowtorch. During the Korean War, mobile Army surgical hospitals, or MASH units, were set up as close to the front lines as possible, while still trying to keep the doctors out of harm's way. The result is that many people died on stretchers and in jeeps on the way to get help. Now, cases like the ECS case mean that a hospital could literally be dropped from the sky to the front lines. Sterile, protected medical gear survives the journey and can mean the difference between life and death. First, small metal cables called lanyards are clipped on. These serve as the lid's hinges. Next, a hole is routed and trimmed for the pressure relief valve. This helps to depressurize the case during air transport. Then, the case is handed off to a second workspace where the latches are mounted. Now that the case is assembled, glue is applied to the slot along the edge and fitted with waterproof rubber stripping. Then, the case is submerged to make sure the seal holds. Once it passes the water test, the case is packaged up and prepped for shipping out. No matter what the cargo, at this plant, there's a strong case to be made for it. Coming up on Battle Factory, a how-to guide to putting a roof over your head, and a half-ton pickup that morphs into a super truck. For a downed pilot or a soldier caught in hostile territory, the key to survival is rest and shelter. Elite forces have created training exercises that teach the soldier to build an A-frame shelter that both protects him from the elements and hides him from the enemy. The A-frame shelter breaks down into the frame, the roof, and the camouflage. But before starting on construction, you've got to find the right location. When scouting a location to build a shelter, look for natural camouflage, like a clearing surrounded by a dense thicket of trees, with plenty of fallen branches, twigs, and leaves to use as construction material. The ground should be level so the structure will be stable, and so water will drain away from the shelter. The optimal site would be hidden from view, but still have access to water and food in the form of edible vegetation like berries or mushrooms and bugs for a crunchy protein snack. The first thing to consider is the size of the shelter. It's got to be long enough to provide cover from head to toe. An operative will lie down to mark the length with sticks. Bedding comes first. The shelter is built around it so the frame isn't toppled over while trying to get the bedding in. Tree bark and fir branches create a soft, comfortable surface that separates the body from the ground to keep cold and damp out. More body heat is lost to the ground than to open air. The A-frame is made of 3 strong branches. The arms, which are made of 2 pieces of equal length, support a spine called a center pole, which runs lengthwise from the arms down to the ground. If they can be found, arms with forks at one end are best for supporting the center pole. The length of the arms determines the height of the shelter. Lower shelters do a better job of retaining body heat, but limit maneuverability inside. Flexible cedar branches act as a natural twine to tie the arms together. On June 2nd, 1995, fighter pilot Scott O'Grady was shot down over Bosnia, forcing him to parachute into hostile and desolate forest. Without food or water, O'Grady knew he had to keep out of sight and stay alive until help arrived. He'd have to rely on his survival training. By day, he slept in shelters built with whatever he could find on the forest floor. He traveled by night to avoid detection. Subsisting on plants, bugs, and rainwater he collected in a sponge, O'Grady managed to survive and evade capture for 6 nights before being rescued by the Marines. First, the woods are foraged to collect branches of increasing height to line up with the angle of the central pole. If need be, the branches can be snapped into size or cut with a pocket knife. The roof is constructed by leaning branches against the central pole a few inches apart in order to form slats. Once the slats are complete, young leafy branches are threaded through and piled on to create a weatherproof thatched roof. This thatched roof will keep out wind, rain, and snow while trapping body heat inside the shelter. For a soldier stuck behind enemy lines, survival also means avoiding discovery and capture. So the shelter is draped in natural camouflage made of fallen leaves. It might not be the best night of sleep he's ever going to get, but the survival shelter means the soldier can stay warm, dry, and alive until help arrives. Coming up on Battle Factory, a bulletproof troop carrier that keeps rolling under fire. Take a standard pickup, strip it down, and build it up with ballistic steel, and an ordinary truck becomes a bulletproof fortress on wheels. The Incus Armored Personnel Carrier is speedy, agile, and bulletproof. It can transport up to 10 troops or police in and out of hostile territory at 90 kilometers per hour and keep them safe even under high-caliber weapons assault. World War I saw the advent of the Armored Personnel Carrier, the Mark IX, which was first deployed to the Western Front to safely carry infantry accompanying tanks past enemy lines. Now troops could be transported in larger numbers and dropped directly into combat. While production started in September 1917, only 3 of the Mark IXs were made in time before the war ended in 1918. Even though there were only a small number of APCs produced, they forever changed the way battles would be fought. The Incus Armored Personnel Carrier breaks down into the frame, the chassis, and the armor. The Incus Armored Personnel Carrier starts out as a stock Ford F-550 Super Duty truck. The transformation begins by stripping the truck, tearing it down until all that's left is the chassis, a bare metal frame, and the engine sitting on 4 wheels. Now, it's ready to be rebuilt from the ground up. The chassis is reinforced with mild steel, so it can withstand hard riding without cracking. And the brakes and suspensions are tricked out so they can handle heavy armor over rough terrain. The next step is to add the armor, which creates a virtually impenetrable shell able to withstand explosions and enemy assault. But before it can be added, the ballistic steel, called B6, has to be tested. 1 sample square from each batch is pulled, and 3 rounds are fired into the same spot. If none of the bullets pass through the steel, it's considered ready for use. If the metal fails the test, the entire roll is trashed. The bulletproof metal is put into production, and the armor plating can begin. Shapes are carved out with a laser, including the windows and gun turrets. Next, the armor is bent into shape on a 10-ton press. Ballistic steel is also used to fully encase the vehicle's engine in a bulletproof cage, so it can keep running under fire. By the onset of the Second World War, both sides realized the necessity of mobile command and control in wartime. As a result, APCs were produced and employed by both the Axis and the Allies in much larger numbers than before. And the carriers evolved from simple armored cars to the ultimate in sophisticated engineering and highly effective tools of war. Today, they're an indispensable asset for armies around the world. The APC's frame is made from mild steel, Its low carbon content means the metal will flex instead of cracking under the impact of a bumpy ride or bomb attack. The steel floor fortifies the chassis against landmines. The outer frame is assembled, lowered onto the chassis, and welded together. A layer of foam insulation is sandwiched between the steel plates to protect the passengers from harsh weather, as well as providing another anti-ballistic layer. The B6 ballistic metal is then welded to the inside of the hull, making it completely bulletproof. A projectile would need to puncture the mild steel, pass through the foam insulation, and penetrate the ballistic steel in order to hit and harm the vehicle's occupants. Nearly impossible. Once the truck has been coated with a textured paint that forms an anti-reflective skin, work is done on installing the bulletproof windows, the seats, and the dashboard. After hundreds of work hours, the armored personnel vehicle rolls off the line for a test drive, pushing it to the speed limit on the highway, then knocking it around to make sure it's off-road ready. Converting a stock pickup into an armored vehicle is like turning a mortal into a superhero. And when the transformation is complete, this monster truck is unstoppable.